Towards the end. Okay, the first one that you have to do is 1.1. So what I did was I just drew the picture and then I wrote like on the side kind of what my thinking was. Okay, because I decided the difficult part of this work is actually figuring out what you need to do. Because often you can't just use the formula straight away, you need to find like in between things. So for 1.1, they ask for the area and the perimeter of the shape. Now, if you're looking for the area of the shape, you have to find the area of the top triangle, which you could actually find straight away. Remember, the area rule is half a side times another side, and then times sine of the included angle. Okay, so we actually had enough information to find the area of triangle ABC. But to find the area of triangle BCD, now you have to realize that this is a right angle triangle, right? So for this one, we're going to have to say half base times perpendicular height. So we have the perpendicular height, but we need to find the base. All right, so that's my next thinking. Okay, how am I going to calculate CD? Because I didn't have BD, I can't use Pythagoras, right? But I can actually find BD. All right, so that is that whole common side we're going to be discussing today. So if I'm going to calculate the common side BD, then I can use Pythag in this triangle to find CD. So guys, it is important to just kind of first figure out what you need to calculate before you just kind of go rushing through the whole thing blindly. Okay, so to find BD, if you're looking at this triangle, you could use the Cogs rule straight away because you had the other two sides and the angle that was opposite to you. So that's what I did to find BD. Okay, I used the Cogs rule for that one. And now because I'm going to have to use my answer for BD to find CD, you have to keep that in your calculation. Okay, so Cosine defines BD, Pythagoras defines CD. Please remember, if you are using Pythagoras, you do have to write that reason there. Okay. And now once I had my CD, I could actually find the area of this whole shape. Right? Area of the top triangle is those two sides and sine of the included angle. Area of this bottom one is half base times perpendicular height. Area, we'll talk about perimeter just now. Guys, I do suggest that if you're finding the area of the shape that has multiple shapes like this, first you each area shape again and then add it together. See if you can do it in one calculation and save you some time. So this area calculation was using area rule. And this one was using half base times perpendicular height. And one triangle was not a right angle triangle, so you have to use area rule for that one. The other one was right angle, which is another thing here is when you found your answer to CD over here, right? You have to store it in your calculator or just put it in your calculator and use the answer button down there. So if the decimal is like different from mine, you could do that. Which one for the area? Did you keep it in your calculator file? Okay, so I check my BD, I'm getting the same thing, and then when I do CD, I must do that squared minus 7 squared. So I'm doing the same thing. Just check quickly. So up here, You guys do cos of 70. Maybe do sine. Yes, I'm doing 12 squared plus 4 squared minus 2 times 12 times 4 times cos of 70 equals. Alright, I'm doing that one. Then I square root. Okay, so that's really that I'm putting in my calculator. So then I do this squared minus 7 squared. I'm giving 78,166 and then square root. Right, for the perimeter of the scripture, go back after the picture and I'll show you the working again. Perimeter of this shape, remember, is all the sides all around. So we would have to do AB, which is 4, oops, that's very sweet. AB, which is 4, and then we have to add BC, which is 7, and then we have to add CD, which we calculated, and then we have to add AD, which is 12. All right, you're not going to do the perimeter of that triangle and of that triangle and add them together. It's just the sides all around the shape. So it's just those four. So for perimeter, it's just adding. You basically just need to make sure that you have all the sides that you need to add. So in a few quick now, guys, you don't really have to write that line down. That's just basically for you so that you could see which ones are added together. So it's just those four sides around the outer edge of that shape. Any questions on 1.1? I need to want to start with. Sorry about that. Then the next one was the all that's broken up. Okay, for 1.5, you now had to recognize that the growth is clear when this triangle is right angle. So remember, we can use pi, sag, sine, cos, tan in this one. This one is non-right angle, so we can use sine rule, cos rule, and if we have to find an area of this one, we're going to have to use area rule. Okay, now for 1.5.1, they're asking for angle DBC, which is this angle over here. That's one there. Now guys, that is an angle in a right angle triangle. So I'm not sure if you guys would have thought to do that. We haven't really practiced this in a while. But find an angle in a right angle triangle. You can just use sine cos or tan. So let's see, we have two of the three sides of this triangle, right? We have that 24 millimeters and we have that 40 millimeters. Now guys, in terms of this angle, do we agree that 24 is opposite that angle? And 40 is the hypotenuse. Which trig ratio works with opposite and hypotenuse? Sine. Alright, so actually we could have just used sine. I don't know if you would have thought to do that if you practiced this in a while. In a right angle triangle, we could have just said sine of this angle is opposite 24 over hypotenuse 40. Alright, so that is where that comes from. Opposite over hypotenuse. And then from here, it's almost like when we use the sine rule, right? We have that sine of an angle is equal to a positive value, so it's quadrant 1 or 2. Find your reference angle by doing shift sign, right? That's 24 over 40. You get your reference angle, which is 36, and then you do your quadrant 1 solution, your quadrant 2 solution. Alright, so I got those two. So guys, remember for your quadrant 2 solution, you always have to check, right? Because if I have a 90-degree angle there, I can't have another obtuse angle, right? I can't have a 90-degree angle and a 143-degree angle, right? That can't happen. If I say 143, so that would be the check, which you can just like do on the calculator or in your head. If you do 143, 13, right, your quadrant 2 solution, plus the angle that you have in that triangle, which is 90, right? You're going to get 233,13 degrees. And is that possible in a triangle? No. Right, this is greater than 180, which is why the answer is 11. So you don't have to really write that last line there. It is in the answer. In the book, just saying, is that one. So this is a tricky one, guys, because we have to remember what we do in a right angle triangle, and then we also kind of have to think about the ambiguous case thing. If we had used cos in the tan, which we can do in a right angle triangle, right? If we have this side, for example, if they told us that this is like 12 millimeters, just making that up, then we could have said cos of BBC is 12 over 50. Then we wouldn't have had to do anything. Okay, so because it's fine, it's because of this thing. It's because sine is positive in quadrants 1 and 2. If you're doing sine, you need to consider it. Alright, 1.5.2, what's an icon? They asked us to calculate AC. So now AC is a side in the non-right angle triangle. So either side will plot. And hopefully you notice that we have the other two sides and the inverse angle, so that's cos rule, right? So AC we can calculate quite easily using cos rule. Maybe you take the side that you're finding squared is equal to the other two sides squared added together, right? 50 squared plus 45 squared minus 2 times the other two sides times cos of the inverted angle. You work that out and then you square it. Okay, now I didn't fill in my values as I calculated them, but it is a good idea to just do that. So sorry, let me just quickly. 36, I'll move over to the working now again. This is 36.87 and AC is 29.45 millimeters. Because now in the last question, we actually need to do some of that information. Or if I was finding AC, and the last question, they now again ask for the area of the whole thing. And guys, that is quite a common question, especially in the fifth final. There is usually a question where they have like multiple triangles put together and you can find the area. So I just quickly want to go back to the picture. I'll come back to the answer just now. If we have to find the area of this whole shape, right? We have a right angle triangle. What's the area of a right angle triangle? Half base times perpendicular height. So we need CB, which is, we can say CB is the base or the height, it doesn't really matter. And then you need the line, the side that's perpendicular to it. So we need BB, right, in order to find this area. So guys, this is a right angle triangle. I have 24 and 40. How can I find the third side? Using hyphen. Okay, third side. All right, so you're going to say 40 squared, because that's the hypotenuse, minus 24 squared. Work that out and then get the square root. So that is how I got that BB was 52 millimeters down there. Right, I figured out firstly that I need that side, right, because I need the two perpendicular sides, the other side. Find the area. So I'm using pi guy to get that one, and then 32. And then from there, again, the first triangle, ABC, was not a right angle triangle. So for this one, I'm using, so not sine rule, I'm using area rule. And for the other one, which is the right angle triangle, I'm using half base times perpendicular height. And unfortunately for this section, you can't just like go into it and just feel like, okay, I'm a student class, I'm gonna know what to do. You definitely have to know your formula and have to apply it. Otherwise you won't be able to do it. Are there any questions on that? All right, I'm going to go on to the next one now, which was that circle question. And guys, also with these questions, sometimes there is more than one way of doing it. So don't stress if your answer doesn't look exactly the same as mine. This is going to run through what my thinking was. Okay, we needed to find x, which is the side over here. So then I'm thinking to myself, okay, x is the side of this triangle here. Looks like I can find some information in this triangle, right? Because I have that 15 also. So in this triangle, let me highlight this for you guys. This triangle ABD. I'm going to probably just work in that triangle and see what I can find. All right. So I want to find x. Do I have the opposite angle to x? No, but can I work it out? What do we see here? What is this? They showed us that AC goes through the center of the circle, right? So AC is a diameter. So that means that this angle is a 90-degree angle. That's useful, right? Because if that whole angle is 90 and that angle is 16, then this angle, which is opposite side x, is going to be 90 minus 16, right? Which is going to be 74. I'll show you now. I have written all of it down here on the side. All right, so that's good. We want to find x. We now have the opposite angle thing. Let's see, if I want to use sine rule, I need another pair of an opposite side and angle, right? So I have 15 as well. Do I have the angle that's opposite 15? No. But let's see if there's a way for us to find it, right? My initial thought was, this is a triangle. Can't I use angle from a triangle? Yes, but not quite yet, hey, because I don't have that angle there. You need to know what that is. Yes, angle is 10 segment, guys. Did you notice? BC subtends a 16-degree angle there, and also there at angle A. So angle BAC is actually also 16 degrees because of angles in same segment. Then you could use angle sine and triangle in this highlighted triangle to get angle B, which was 46 in the end. I'm going to show you now how I wrote everything up, but I'll be okay up until that point, guys. So basically, you figure out, okay, I'm going to try to use sine rule. What do I now need to find in order to use sine? Okay, so first, angle in semicircle to get that 74, and then angle in same segment to get that 16, and then angle from a triangle. Right, then we could use sine rule. So we're going to say x over sine of the opposite angle, which is 74, is equal to 15 over sine of 46. All right. So guys, you would have to write all of these things down, right? With all of these relations. You would also get marks for that. Right, when you guys are done copying that down, we're going to do one example and then you're going to do some more work on your own. Basically, also the key to being able to do well in this section is just as much practice as possible. So that's actually combining all the bunch of different topics into one section. Right, if you're done, then you can try the example. Have to have another heading, just say example. Alright, here we go. So it's just one basic triangle, but now guys, the only thing here is that we're not working with any numbers, we're now working with variables. Okay, so we need to work with that kind of thing. As well, so we need to find the letter B. in terms of the given symbols. Right, I'm also just going to highlight BC. It just kind of helps to know what we're trying to find. So guys, if we take in terms of those symbols, that means that our answer has to have those symbols in it. Right, so we're going to have BC is equal to something with theta, beta, and x. Right, we're not solving for x, we're not solving for theta or beta. Nowhere here are they saying solve for any of those variables. We need to write BC equals, and then our answer has to have those symbols in it. So we're not going to get a number as an answer. Okay. Now guys, this is a non-right angle triangle, right? Here we don't have any 90-degree angles here, so we need to either look for, can we use sine rule or can we use cos rule? Okay, we need to find these. So guys, for sine rule and for cos rule, right, doesn't matter which one I use, I need the opposite angle to use, which I don't have. Okay, I'm going to need angle A. But can I find angle A? Okay, we're going to yes, yeah, we can. All right, we're doing 180 minus those two. That's going to write it slightly differently from how we normally do, and we'll see why just now. I'm going to say angle A is, normally we would say 180 minus theta, but I'm actually going to write it like this. You see, when we put it in our sign rule, you see why it's actually important to write it like this. We need our reason angle sum in triangle. Okay, so that's all we need to be able to do sine rule. Let's see, BC over sine of A, which we now have, is equal to, there we have our other thing. Right, x over sine theta. All right, so let's do that. So therefore, BC over sine of this whole angle, now you're going to have to use square brackets around this angle because we do have round brackets there. So BC over all of that. Is then equal to x over sine theta. So guys, the reason why I wrote it as 180 minus the bracket is because we're now going to have to use a reduction formula. Yeah. Right, 180 minus is always quadrant. 2. Remember? 180 minus is quadrant 2. What is sine in the first quadrant? Sorry, I said first, I mean second. Sine in the second quadrant is positive. So guys, we have to write it as 180 minus a bracket so that I can drop that 180. minus. Okay, so now in the next line, I'm just going to rewrite this as BC over sine of now just the bracket. And that is equal to x. Alright, so that's an extra thing that you need to remember, please, guys. I think I'm going to make a note just here, maybe on the side, or if you have space above, just somewhere with the 180 minus. Right, like this, so that we can use problem 2. If you had the person 180 minus theta, then you wouldn't have been able to do it. Alright, now the next thing is we obviously need to get BC on its own, right? Because it says find the length of BC in terms of the given symbols. So this is what we've been doing so far. We're now going to times by sine theta plus beta on the other side. So we're going to say BC is equal to this fraction that we already had on that side, x over sine theta times sine theta plus beta. But now, guys, that actually is not simplest form. Right? That is one term. Do we agree with that? What we have on the right thing. It's one term. It's a fraction, which is one term, times something else. All right. And times doesn't separate them. So this is one term. But guys, that's not the simplest form. The simplest form. Hello?
I'm sorry, I'm on a delivery from.
Oh. I was wondering. All right, guys. Now for this one, how do you think we're going to make this simpler? So that it's not two separate parts, but maybe as one fraction. Is this not the same as sine theta plus beta over 1? Okay. And what happens here? We can just multiply the two numerators together and multiply the two denominators together. Okay, so we actually have to do that, guys. We have to put x sine theta plus beta as our numerator over sine theta times 1, right? Which is just sine theta. Okay, so your answers, guys, you always have to leave them in simplest form. So not two separate parts. If it's a fraction multiplied by something, you have to write it as one term. Okay. Now, what I don't want you to do, please, I'm going to show you now. I've seen this happen many times before. Some people will be like, oh, nice, there's a sine there and a sine there. And even better, there's a theta and a theta. Right, so my answer is x beta. You can't do that. Okay, you're not allowed to. Sine is not a thing on its own. All right, if you had this, if you had x sine theta over sine theta, yes, then you could cancel out the sine theta. Okay, but you can't cancel a theta from a bracket with a theta. That's not good. Okay, just be aware of that. Right, guys, you're going to practice, I think it's 2 questions like this, with a variable, but then also 2 questions with numbers again, just so that we can get as much practice as possible. I still have half an hour left. Okay, so see how much of this you can do in that time. The first one, 1.6, is a number question, I think. These 2 are variable questions, and then that's another circle one. Okay, I'm trying to make you guys practice the different types all together. I don't want to do them like separately, so it's fun. No, do people get one? Right, so you can get going on that now.